Good afternoon, students. Welcome to the 43rd lecture of refrigeration and air conditioning subject. Today, the topic to be discussed is human comfort, factors affecting human comfort, quality and quantity of air. So, today's topic we discuss regarding the quality and quantity of air and also the factors affecting the human comfort. Yes. Uh, right. So, the human comfort mainly depends upon the physiological and psychological conditions. Physiological means the human body shape, size, his body nature, the weight, etc. And psychological means whatever the human whatever the person will behave. It may be cool, it may be warm, it may be discomfort, it may be headache, it may be noisy, it may be whatever it is. So this depends upon the human comfort. So the human comfort depends upon mainly physiological and psychological conditions. So it is difficult to define the term human comfort, right? There are many definitions given for this term by different bodies, but the most accepted definition said by AHRAE, Refrigeration, American Society of Heating, Refrigeration and Air Conditioning Engineers, states that human comfort is the condition of mind which expresses satisfaction with the thermal environment. So it is the comfortness of the person, the comfortness, that a condition of mind. So whatever the mind thinks physically and mentally, so it has to react with the surroundings what it is having, right? Next. So if you see the illustrations of the human comfort, see here. So the boiler can be compared to the human body in that it uses fuel for energy. Okay, the boiler can be compared to the human body. The boiler can be compared to the human body in that it uses a fuel or for energy. So the boiler uses generally different categories of fuel. That is, it may be coal, coke, it may be oil, or it may be electric. Now, if you see the boiler which is having the heat system building radiators wire, so the relief valve and the heat from the flue and the heat in the smoke. So this is a boiler setting where we are dumping the material inside through this aperture, thereby the smoke is going from this tube and we are having the heat from the flue and the relief valve, right? So this is a relief valve. So the heat through skin of the boiler, the heat through the skin of the boiler, even though it is insulated, right? The condensate return at this point. Now, if you see the human body, the body's normal temperature is 37 degrees centigrade. Okay, the normal human body can persist up to 37 degrees centigrade. The heat flowing from the body to ambient air at just the right rate, that is humidity 22.8 degrees centigrade, that is 50% humidity. Now, the human body must give off some of its generated heat to the surroundings. So, what happens? So, generally, the human body also consists of some sort of energy, right? Some sort of heat. So, from the human body also, some sort of heat will be coming out, right? Heat will be coming out. Therefore, we have sufficient amount of heat in our body, depends upon the body weight, body mass index, body uh, physical capacity. So we have to generate it. So we are generating some sort of heat that is sending to the surroundings. So the ambient temperature is 37 degrees 0.8 degrees centigrade, but the body temperature is 37 degrees centigrade. So if you see, the body is having the evaporation of respiration, the water vapor, the perspiration. So for example, in a summer season, if you are going out on a sunny day, so at a certain point of time on a high heat conditions on the road, the body will become nervous, the body will become fainted, and will become dizziness. All the water inside the body will be sucked by the atmosphere, which is outside. Then what happens? Your body will get perspiration, water vapor, so it will get dehydrated. So whenever you are getting dehydrated, you require water to drink, right? That sort of things also can be experienced when you are feeling some sort of discomfort. Next. Now see here, the three direct ways the human body gives off the heat is, so generally you know that first one is a conduction, next one is a convection, third one is a radiation. The heat loss by the convection QC from the body to the surroundings is given by QC is equals to UA of TB minus TS. Okay, UA of TB minus TS. So what is U here? U is equals to body film coefficient of heat transfer. Body film coefficient of heat transfer. Capital A is equals to body surface area, that is equals to 1.8 meter square for normal man. TB is equals to temperature of the body. TS is equals to temperature of the surroundings. Now see here, the heat loss by conduction process. So what happens here? The heat is going outside from the body, right? That it is conduction, heat loss due to the conduction. Next, heat loss by convection process. The heat lost by the convection process. So here what happens? Here the body, here the heat is lost by this convection. Here the body, here the heat is going outside, right? Now see here, the heat losses during radiation. So what happens if you are having a black body? So due to this black body, we are getting some radiation effect. For example, if you wear any black dress, what happens on a hot summer season if you wear black dress? The black color will absorb the radiation from the sun and you get more heat. That is nothing but radiation. Next. What are the factors affecting the human comfort? What are the factors affecting the human comfort? In designing, in designing the winter or summer air conditioning system, winter air conditioning, summer air conditioning system, the designer should be well conversant with a number of factors with physiologically affect the human comfort. The important factors are as follows. So what are the factors to be considered? First one is effective temperature. First one is the effective temperature. Second one is heat production and regulation in the human body. The first thing is effective temperature. The first one is the effective temperature. Second one is heat production and regulation in the human body. The third one is heat and moisture loss from the human body. So from the human body, whenever the water content is evaporated, we are getting moisture loss. Then the person will get dehydrated. So that's why every time the body should be hydrated. Heat and moisture loss from the human body. Fourth one, moisture content of the air. Fourth point is moisture content of the air. Fifth one is quality and quantity of air. So what is the next thing? Quality and quantity of air. Sixth one is air motion. How the air is having the motion. How the air is moving here and there and also in the closed spaces. Next, hot and cold surfaces. Next affecting factor is a hot and a cold surface. Next, air stratification. So these are the 8 factors that are affecting the human comfort. Next one is quality and quantity of air. So how does we realize the quality and quantity of air with respect to the human comfort? The air in an occupied space, the air in an occupied space, whatever the outside space or inside space, so generally whatever the air occupied in the space, all the times be free from toxic, unhealthful or disagreeable fumes such as carbon dioxide is present. So generally whatever the air is occupied, for example in a room, generally the air is occupied. So in a room with a capacity of 10 persons, if more than 15-20 persons are accumulated in a room, then what happens? Automatically the room will the persons will get suffocated, and release of unhealthy and toxic fumes will be liberated from the space. It should be free from dust and odor. In order to obtain these conditions, enough clean outside air must always be supplied to an occupied space to counteract or adequately dilute the sources of contamination. So what it is saying here, so whatever the space, whatever the air is there, it should be free from dust and odor. So in order to obtain these conditions, enough clean outside air must always be supplied to the occupied space to counteract or adequately dilute the sources of contamination. Now, the concentration of order, the order concentration. So if some concentration is high, some concentration is low. The concentration of order in the room depends on what? Many factors such as dietary and hygienic habits of occupants. Dietary and hygienic habits of occupants. Type and amount of outdoor air supplied. Type and amount of outdoor air supplied. Room volume per occupant and types of order sources. In general, when there is no smoking in a room, okay, 1 meter cube per minute, okay, 1 meter cube per minute, a person of outside air will take care of all the conditions. When the smoking takes place in a room but when smoking takes place in a room, 1.5 meter cube per minute per person of outdoor air is necessary. Okay, in most of air conditioning systems in most air conditioning systems a large amount of air is recirculated. In most of air conditioning systems, what happens? A large amount of air is recirculated over and above the required amount of outside air to satisfy the minimum ventilation conditions in regard to outdoor and purity. For general application, a minimum of 0.3 meter cube per minute of outside air per person mixed with 0.6 meter cube per minute of recirculated air is in good condition. Okay. Now, what are the factors affecting the optimum effective temperature? So, what is the point here? What are the factors that are affecting the optimum effective temperature? So, the factors that affect the optimum effective temperature are: first one is climatic and seasonal differences. Climatic and seasonal differences. So, it is known fact that the people living in colder climates feel comfortable at lower effective temperatures. Absolutely, the people who are living in the colder climates, absolutely, the people who are living in the colder climates feel comfortable at lower effective conditions than those of the warmer regions. So absolutely, the people wherever they are living in high hill stations, they feel comfortable at low effective temperatures than that of the warm region. Next, there is a relationship between optimum indoor effective temperature and optimum outdoor effective temperature. So what is happening here? There is a relationship between the optimum indoor effective temperature and optimum outdoor effective temperature, which changes with seasons. We see from the comfort chart that in the winter season the optimum effective temperature is 19 degrees, whereas in the summer season it is about 22 degrees centigrade. Next, second one is clothing. The second effective optimum temperature is clothing. So it is another important factor which affects the optimum effective temperature. And another important factor which affects the optimum effective temperature is clothing. A person with light clothings need less optimum temperature. Okay, a person with light clothing. A person with light clothings need less optimum temperature than a person with heavy clothing. Next one is age and sex. So what happens to this age and sex here? So here we have discussed the women of all ages require higher effective temperature than men. So similarly, similar is the case with the young people and the old people. The children also need higher effective temperature than adults. Okay, that children also need higher effective temperature than adults. So the veterinary halls are always kept in a effective temperature about 2 to 3 degrees centigrade higher than that of the temperature used for the adults. Next fourth point is duration of stay. Means how much time the person will stay in a room. So it has been established that if the stay in a room is shorter, okay, for example, if a person is staying in a room at a shorter period of time, and then a high effective temperature is required than that needed for a long stay, as in case of persons working in a office. Now, the kind of activity, when the activity of a person is heavy, when active means the person what he is doing, when a person an activity of a person is heavy such that the people working in a factory dancing hall at then low effective temperature is needed than for the people sitting in a cinema hall or auditorium. Next one is density of occupants, means how many people are occupying in a room. The effect of body radiant heat from the person to person particularly differs. Occupied in a space like auditorium is large enough which require a slight lower effective temperature. So that is also one of the factor for optimum temperature. Next. Next one is troubleshooting. Next concept is a troubleshooting. The troubleshooting means whatever the problems occur in any software or whatever the problems occur in any electronics equipment or any other machinery. The troubleshooting means we are checking for some defect in the device. So the troubleshooting in air conditioning equipment involves both the mechanical systems as well as the electrical systems, right? The troubleshooting involves both the mechanical as well as the electrical systems. Then the symptoms may overlap depends upon the feature to feature. The mechanical problems may appear to be electrical and vice versa. So the mechanical problems may appear to be electrical, vice versa. The technicians must diagnose problems correctly. So whatever the person, whoever the person is doing the troubleshooting must diagnose, means must check the devices carefully in order to eliminate the problems. Next, what are the mechanical troubleshooting process? See here, the gases and temperature testing equipment. The gases and temperature testing equipment are used when performing mechanical troubleshooting. Okay, the gases and temperature testing equipment are used when performing the mechanical troubleshooting. So we are using gases and also the temperature testing machines whenever you are going for the mechanical troubleshooting. Always be aware of the system refrigerant. So we have to know that what type of refrigerant you are using for the air conditioning system. Next, R410A pressures are much higher than that of the R22 refrigerant. Now, the R22 gauges and temperature testing equipment. Okay, R22 gauges on off 10 410A systems will be over pressurized and can be damaged. So, not all refrigerants oils are compatible. So, gauges should be used only for one type of refrigerant. Next, coming to the sizing of air conditioning systems. So, if you see the physical capacity of an AC, that is size, shape, orientation, position, whatever it is, how large your home is and how many windows it has. So we have to see which one. So we have to check the what is the capacity of a room, what is the capacity of a house, means length, width and height. That is a volumetric cubic thing. So how large your home is and how many windows does the home has. Next, how much shade is on your homes, how much shade is on your homes, windows, walls and roof. So what is the meaning of this one? So how much shade means how much shade is following is flowing, means whenever the sun is falling on the house, shadow, how much shade you are having, means how far the roofs, windows, walls are saved from the sunlight. Next, how much insulation is in your home ceilings and walls. So what is the thing next you have to find? So we have to think of how much insulation means covering, okay, protecting the house. How much insulation is in your ceilings and walls, that is the pop, or it may be your thermocol sheets, whatever it may be. Next, how much air leaks into your home from the outside. So next point is how much air will get leaked. How much air is leaking into your home from the outside. బయట నుంచి how much air is leaking from your home. Next one is how much heat the occupants and appliances in your home generate. Means, for example, in your home, if you are staying for more than 5 members, what is the heat generated from the 5 members, and also the appliances means it may be the electrical or electronic gadgets where the heat is produced, right? Next, energy consumption, how much energy you are consuming. the air conditions the air conditions are rated by the number of British thermal units. So the air conditions are given by the rating such as BTU. BTU means British Standard Units. British Thermal Units of heat. They can remove the per hour. So per hour, how much amount of BTU is done. So air conditioning measure can be checked by using this measurement such as how much power it is being done. That is British thermal units of heat can be removed per hour. Next. Another common rating term for air conditioning size is the ton. Okay. Another common rating term for air conditioning size is a ton. So we can rate the air conditioning systems by using the tonnage, which is 12,000 BTU per hour. 12,000 BTU per hour. Right? Next. Room air conditioners range from 5,500 BTU per hour to 14,000 BTU per hour. Okay, so what is the next point it is saying? The room air conditioners ranges from how much? 5,500 BTU per hour నుంచి 14,000 BTU per hour. Next one is energy efficiency. So today's best air conditioners use So today's generation, air conditioners are using 30% to 50% less energy than 1970s. So old model refrigerations versus new model refrigerations. If you see, the energy efficiency is increased up to 30% to 50%. So that's why if you see nowadays if you see present refrigeration systems, you are having the 5-star rating. So what is the meaning of this 5-star rating? So if you are having 2-star rating, so your current consumption is somewhat high. So if you are having 5-star rating for your refrigeration, automatically the cooling effect, the current consumption is low, and also you are getting less power bills. So that is the concept of this efficiency improvement. Next. Next point is check. Even if you even if your air conditioner is only 10 years old, you may can save up to 20 to 40% of your cooling energy cost by replacing it with newer or more model. So this efficiency can be even shown like this also. Even to you can save 20 to 40% of your cooling energy cost by replacing it with the newer or more efficient model. Next one is measurement of psychometric properties. Next topic to be discussed is a psychometric properties. So based upon the Gibbs phase rule, what we have studied in the metallurgy and material science, Gibbs phase rule, the thermodynamic state of moist air, okay, the thermodynamic state of moist air is uniquely fixed with the barometric pressure, and to other independent properties are known. Okay, this means that a given barometric pressure, the state of moist air can be determined by measuring what? By measuring any two independent properties. Okay, so about the between the two independent properties, one of them could be the dry bulb temperature, that is dBT, and wet bulb temperature. The dry bulb temperature, as the measurement of this temperature is fairly simple and accurate. Next one is the accurate measurement of other independent parameters such as humidity ratio is very difficult in practice. So what is the next thing? The humidity ratio is very difficult in the practice. Next, the measurement of temperatures is easier. Since the measurement of temperature is easier, it could be convenient if the other independent parameter is also a temperature. So what is the next parameter? The measurement of temperatures is easier. It could be convenient if the other independent parameter is also a temperature. Of course, this could be the dew point temperature. The next one is the dew point temperature. But it is observed that the accurate measurement of dew point temperature is difficult. So in order to measure the accurate dew point temperature is difficult when compared to the first thing. Therefore, a new independent temperature parameter known as wet bulb temperature is defined. So in order to get the redefined solutions from the dew point from the dry wet bulb temperature, we are using wet bulb temperature is defined. Compared to the DPT, it is easier to measure the wet bulb temperature of moist air. So, knowing the dry bulb and wet bulb temperatures from the measurements, it is possible to find the other properties of moist air. Next one is cooling load calculations. How you are calculating the cooling load. Okay. Next, the last topic in the unit 5. The cooling load calculations involve the systematic and stepwise procedure that takes into account all the relevant building energy flows. So what it is saying here, the cooling load calculations involve a systematic and stepwise procedure that takes into account all the relevant building energy flow. The cooling load experienced by the building, okay, whatever the building you are having, commercial building or a domestic or appliances, domestic building, the cooling load experienced by the building varies in magnitude from zero, that is non-cooling required, to the maximum value. The design cooling load is a load near the maximum magnitude but not normally the maximum. So what it is saying, so the design of the cooling load is the load near to the maximum magnitude. So for example, if you are having the the limit of minimum to maximum, it is the load near to the maximum magnitude, but it is not normally the maximum. Design cooling load takes into account all the loads. So what it is saying here, design cooling load takes into account all the loads experienced by the building under a specific set of assumed conditions. Next point. More accurate load estimation methods involve a combination of analytical methods and empirical results obtained from the actual data. For example, the use of cooling load temperature. Okay, the use of cooling load temperature difference, that is C, L, T and CLTD. So for estimating fabric heat gain and the use of solar heat gain factor. Now, the solar gain heat factor for estimating heat transfer through fenestration method. These methods are very widely used by air conditioning engineers as they yield reasonably accurate results. And estimations can be carried out manually in a relatively short time. So what it is saying here, these methods are widely used by air conditioning engineers, okay, and can be carried out manually in a relatively short period of time. Next, over the many years, more accurate methods that require the use of computers have been developed for estimating the cooling loads. Example, transfer function method TFM. Since these methods are expensive and time consuming process, they are generally used for estimating the cooling loads of large commercial and institutional buildings. So, Heat American Society of Engineers suggests different methods for estimating the cooling and heating loads based upon the applications, means based upon the usage what they are doing, such as for residential applications, commercial applications, and industrial applications. So the assumptions behind this design cooling loads are as follows. So these are very important things. The design load calculations, the assumptions. First assumption is design outside conditions. Design outside conditions are selected from a long-term statistical database. The conditions will not necessarily represent any actual year, but are representative of the location of the building. Now, design data for outside conditions for various locations of the world have been collected from and are available in a tabular form in various handbooks. Next point. The load on the building due to the solar radiation, okay, the load on the building due to the solar radiation is estimated by clear sky conditions. అంతే కదా, the load on the building due to solar radiation is estimated by the clear sky conditions. The building occupancy is assumed to be the full design capacity. So whatever the design you are doing for the building, so whatever the occupancy is assumed to be the full design capacity. All building equipment and appliances are considered to be operating at reasonable representative capacity. So what is the next point? It is saying that all building equipment and appliances are considered to be the operating at the reasonably representative capacity. Now, the total building cooling loads, the total building, the total building cooling loads consists of heat transferred through the building envelope. The total building cooling load consists of heat transferred through the building envelope. Means what is a building envelope? Surrounding of the building. There is a walls, roofs, floors, panels, sheets, windows, doors, glass doors. And heat generated by the occupants. And inside the building, how the heat is generated? The heat is generated by the human beings, that is occupants, equipments as the machinery and the lighting what you are having. The load due to the heat transfer, the load due to the heat transfer through the envelope is called as external load. Now, all other loads are called as the internal load. What are the loads? Internal loads. The internal loads are the occupants, equipment, and lightings. Then, what are the external loads? Walls, roofs, floors, windows, doors, and glass doors. Now, the percentage of external versus internal load varies with the building type. So building type means what type of building you are having, commercial building or domestic building. Inside that commercial building, what type of structure you are having. So all these things, the site climate and the building design. The total cooling load on any building consists the total cooling load on any building consists of both sensible as well as a latent loads. Okay, sensible heat as well as a latent load. The sensible load affects the dry bulb temperature while the latent load affects the wet bulb temperature. Next, the buildings are classified as external loads and internal loads. What are the external loads? That is the envelope, building envelope. What is the internal loads? That is the occupants, machinery, equipment, and lights. The in externally loaded buildings, in externally loaded buildings, the cooling load on the building is mainly due to the heat transfer between the surroundings and the internal conditioned space. Since the surrounding conditions are highly variable in any given day, the cooling load of an externally loaded buildings vary widely. In internally loaded buildings, the cooling load is mainly due to the internal heat generating sources such as occupants or appliances or processes. So generally, the heat generation is due to what? Due to the internal and external heat fairly constant, and since the heat transfer from the variable surroundings is much less than that of the compared to the internal heat sources, the cooling load of the internally loaded buildings remain fairly constant. Okay, the cooling load of internally loaded buildings remains totally constant. So obviously, from energy efficiency and economics points of view, the system design strategy for an externally loaded building should be different from a internally loaded building. So what happens here? The prior knowledge means the extra knowledge of whether the building is externally loaded or internally loaded is essentially for an effective system design. Okay, next. Now see the simple illustration of the group of occupants inside the room. So how many occupants? 1, 2, 3, 4. So the internal heat sources. So this is a occupants, this is a equipment, right? And the lighting source. Now the heat transfer from the ground, right? And the heat is transferred from the top and the solar radiation through the opaque surfaces. opaque, this is the opaque surfaces, and solar radiation to the penetration, and the infiltration process through the gaps. So these are the various factors of heat entering or transferring into the building. So the total cooling load on the building consists of the external as well as the internal loads. The external loads consist of heat transfer by conduction through the building walls, roofs, floors, doors, etc. Heat transfer by radiation through fenestration such as windows and skylights. All these are sensible heat transfers. In addition to these external load, also consists of heat transfers due to the infiltration, which consists of both sensible as well as latent components. The heat transfer due to the ventilation, the heat transfer due to the heat transfer due to the ventilation is not load on the building load but the load on the system. The various internal loads consist of sensible heat, latent heat due to the occupants, products or processes, appliances, sensible heat transfer due to the lighting and other equipment process. Okay, so whatever the figure shows the various components that constitute the cooling load on the building, means these are the factors that are affecting on the cooling load of the building. So in this way, the load calculations are be calculated for any type of building. It may be the commercial building or it may be the domestic building, right? So with this, we'll stop the class, and the topics which in the unit 5 are totally covered in all respectives. So this is a final session of the unit 5. So from tomorrow, we will start the unit 6, that is the last unit. So with this, we can complete the unit 5. So thanks for listening patiently. Thanks for listening patiently. So have a nice day. Thank you.